This question is quite tricky, but once we solve this circuit completely, then you can solve this question hardly in 10 seconds. Now let us consider these resistors are R1, R2 and R3. And if you look at carefully the circuit, then we can find out that one of the terminals of R1 is connected to point A. As far as the resistors R2 and R3 is concerned, now this terminus of R2 and R3 is connected to point A via this wire. So one terminus of all the three resistors R1, R2 and R3 is connected to point A. Now let us consider the second terminus or the remaining terminus. Now the second terminus of the resistance R1 and R2, which is connected here, is again connected to point B via this wire, and the second terminus of R3 is directly connected to point B. So from this discussion, what we can conclude, one terminus of all the three resistors R1, R2 and R3 is connected to point A, and the remaining terminus is connected to point B, which simply means these resistors are in parallel combination with each other. So by simply putting the law of parallel combination, we get the equivalent resistance between point A and B is equal to 1 upon R1, that is 1 by R, 1 upon R2, which is again 1 by R, and 1 upon R3, which is again 1 by R. We can simply put a value over here, or we can write down like this, 3 by R. So equivalent resistance R between point A and B will be R by 3, which is 9 by 3, and hence 3 ohm.